These three are things to be aware of. So we're going to do three problems where they're a little bit trickier than some of the normal problems that we do. First problem will be y equals 2x squared minus 8x. Notice that there's no c term in this, so you could really write a plus 0 if you wanted. So the standard form of this is going to tell us that the y-intercept is at 0. Now, because the y-intercept is at 0, what that does for us is we know that one of the x-intercepts is also at 0. Because if 0, 0 is a y-intercept, then 0, 0 is also an x-intercept. One thing that might help you with is it might help you to understand that factoring this might be the best way of going about it, because if we factor out the greatest common factor, 2x, we're left with x minus 4 as the other factor. So that tells me that the other x-intercept is at 4, 0. I could write this in intercept form really easily. So y equals 2x times x minus 4. And then that gives me some more information. So for example, the vertex is going to be directly in the middle of my two x-intercepts. Since I'm in intercept form, I can tell that's going to be the case. X will equal 2 in the vertex, and then the y value is what happens when we substitute 2 in, so we get negative 8 if we substitute it into the equation, either the standard form or the vertex form. So my axis of symmetry will be at x equals 2. The point symmetric to the y-intercept will be at 4, 0. Because it's twice as far away from it's basically the exact same distance away from the vertex, just on the other side. And so I could write this in vertex form, y equals 2, don't forget the a value, times x minus 2 squared minus 8. And so now graphing this should be pretty simple, because I have a vertex at 2, negative 8, over 1 up 2, over 2 up 8 gives me all of the points that I need. I tried. Smartboard writing is hard. Second problem, y equals negative 2x squared minus 8. One thing that you want to notice about this problem is that there's no b. Because there's no b, that means the x value of the vertex is very easy to get. Since the x value of the vertex is negative b over 2a and b is 0, that means the x value of the vertex is 0. If you substitute that in, you get negative 8. Which also represents the y-intercept, which you can figure out since this is in standard form right away. So since this is in standard form right away, one of the things that we can always notice is the c value is going to be the y-intercept. Once we figure that out, we can also understand that this is actually written in vertex form as well. You can see that because if you do y equals negative 2 x minus 0 squared minus 8, these two things are equivalent. So because that is true, then I can write this in vertex form right now. So y equals negative 2x squared minus 8. That means that I have a parabola that has the vertex at 0, 8, which means my axis of symmetry is at 0. It's just having a vertical shift down 8. Okay, a vertical shift down 8. Then the next thing we might want to talk about is how we can figure out potential x-intercepts. Well, we should know that there are going to be no x-intercepts when we just look at the graph, or when we look at the equation, because the y-intercept, which is also the vertex, is at 0, negative 8, and it opens down. So we could graph this real quick, because over 1 down 2 is our general pattern here. Over 2 down 8 would put us way down there. This graph is opening down. This is never going to cross the x-axis. We cannot write this in intercept form because there are no intercepts. Now, One other thing that we might want to be aware of is if we tried to factor it, what we would get is y equals -2 times x squared plus 4. And x squared plus 4 is not factorable. It is the sum of two perfect squares, which is only factorable into the complex numbers. Um, if you don't want to know about complex numbers until we learn them, uh, you can kind of figure that out later. But we could technically factor this into the complex numbers as -2 times x plus 2i times x minus 2i. But again, 2i and -2i are not they're not real numbers. So they're not numbers that actually show up for us as actual intercepts. The point symmetric to the y-intercept, there is none because it is the y-intercept. The y-intercept is the vertex, so there's nothing that's symmetric to it there. Finally, y equals 1/2 times x squared minus 5. So this is in vertex form already, which means I messed the worksheet up. So you should have intercept form here, although this is technically also an intercept form, so I guess, didn't mess up the sheet. So I could have y equals 1/2 x minus 5, x minus 5, and its equivalent. So if I wanted to write it in intercept form, I guess I could technically write it that way, but I don't have to. I can write it as x minus 5 squared, and that'd be fine. So the vertex, since this is in vertex form as well, we can see that the vertex is at 5, 0. The axis of symmetry is going to be x equals 5. Our x-intercepts are at 5. There's only one of them. The y-intercept we can get by substituting 0 in for x, and we get 25 halves, or 12.5. And the point symmetric to the y-intercept is going to be, since the vertex is at 5, it's going to be at 10. So we have 10, 25 halves is our point symmetric to the y-intercept. If we wanted to write this in standard form, we would distribute. So we would have y equals 1/2 times x squared. That x looks really weird. Looks like somebody running across a finish line. X squared minus 10x plus 25. And then I could distribute that. So I get y equals 1/2 x squared minus 5x plus 25 over 2, which is the same thing as 12.5. So if I wanted to graph this, I would realize that the vertex is at 5, 0. That is my only x-intercept. So one thing that you want to notice when you have a situation like this, when it is in vertex form, when there is no vertical shift, there is only one intercept. Also notice that when, x-intercept. Notice that when you are in this form, you can write it like this, which means that you have the same intercept for the x values showing up twice. So x minus 5 showing up twice in intercept form means that you only have one intercept, and we call that a double root. So that is called a double root. Now it opens up. Since we have this 1/2 here, it opens up over 1 up a half, over 2 up 2, over 3 up 9 halves, over 4 up 8. And then again, if we went over 5 halves, over 5, it would go up to 12.5, which is the intercept of the problem. And that is that.